Hello everybody, my name is Mar Valle and I'm a researcher at the Technical University of Madrid. Currently, I am leading a research in industrial autonomous robotic systems. Since I started investigating in this field, I have realized one thing: the areas of sensing and estimation are an essential aspect in robotic systems. To understand what I mean, just try to think how important are our senses and brain to us. Sensors and estimation algorithms are equivalent to our senses and brain in robotics, and they gain even more importance when these systems are deployed in complex and dynamic environments. So, the general purpose of this presentation is to provide a brief overview of common sensing methods and estimation techniques. I would like to divide my presentation into 5 main areas. First, previous considerations to keep in mind. Then, I'll move on different kind of sensors. Third, estimation technologies and their correct selection. Fourth, representation methods of processed data. And last, a conclusion. Now, I would like to start by looking at previous considerations that I believe are important to know. When we are talking about perception processes, there are 2 main levels. A basic level, where only the internal state of the system is estimated, for example, the position of an arm, and a higher level consisting in the combination of those internal variables with information of the environment, for example, the position of an object. Having looked at the basic considerations, I would like to consider the way sensors can be classified. Sensors are fundamental technologies present in both levels, and 2 main aspects are taken into account when classifying them in an overall manner. First, depending on what they measure, sensors can be exteroceptive, which are those that estimate internal variables of the robot, or they can be exteroceptive, which are the ones that estimate aspects of the external environment. The proprioceptive sensors quantify, for example, the force and torque at an end effector, and the exteroceptive sensors determine, for example, the distance to an object. Second, depending on how they measure the physical aspects, sensors can be active, meaning they emit energy to the environment, for example, an optical barrier, or passive, which means that they determine variables through contact or receiving energy, for example, a potentiometer. Okay, I've talked about sensors, but the truth is that sensory data by itself is meaningless. All the amount of raw data must be computed by different algorithms to create a model of the environment from this data. In other words, sensory data must be interpreted, and this task is known as the estimation process. But it is also true that a huge number of algorithms exist. So how do we select the optimal set of estimation techniques? It is not an easy work. I would like to propose you 2 questions you should ask yourself in order to ease the selection process. First of all, what information is known a priori from the environment? On one hand, if nothing is known, expectation maximization algorithms could be a good choice. On the other hand, if prior information is known, future matching algorithms are the best option without any doubt. Secondly, what information is necessary for the task at hand? If the aim is to make binary decisions, like the case of fitting through a door, problems can be modeled using concepts from decision theory, including, for example, 0-1 loss functions. And these are the 2 main questions you should answer before selecting the estimation techniques. So far, I've concentrated on sensors, types of sensors, and estimation technologies. But once we have the processed data, what is the next logical step? I would like to talk about representation methods, which is the last point. In this section, I'm going to introduce you 3 widely used graphical representation methods of processed data. They are as follows, from the most basic to the most complex. First, grid-based representations. It spatially divides the environment in cells, each of these containing information such as temperature or position of obstacles. Future representations and symbolic-based models are the second and third methods. Both are the most complex methods. The former can represent a larger abstraction of data, for example points and lines, or even more complex geometric figures like planes or curves. The latter can represent non-geometric figures like body structures or road surfaces. Well, I think this covers most of the things I wanted to say about sensing and estimation methods in robotics. To conclude my presentation, I would like to ensure that you have understood the variety of technologies related to sensors and algorithms, and the correct selection is basic for a good interpretation of this world and to carry decision-making processes out accurately. So this is the end of my presentation. I hope you had enjoyed, and goodbye.